So now I've moved from the cluster computer to my personal computer, and what we're going to do is try and find the LS Dyna export file, and then we're going to post-process it using LS PrePost. And the way we're going to access that file is if we go into the directory where we've saved our project schematic, we go into the files, dp0, the system files, and the mech file, we're going to find the LS Dyna export.k file. This file basically has all the parameters, the mesh, and all the individual things that are needed to run an LS Dyna simulation. So we're going to copy that file and we're going to paste it in our desktop. And now what we need to do is, using LS PrePost, we have to create a fluid mesh file and a solid mesh file, which are going to be coupled together in the simulation. So first, we open LS PrePost. And in LS PrePost, we're going to open that export file. So what we do is we go into File, open LS Dyna keyword file. And if we go into our desktop where the file is and the LS Dyna export, we open that file. And there it is. Here you can see with different colors, we have 4 different parts: the inlet, the outlet, the wall, and the leaflet. Using a wireframe view, for instance, or any other type of view in LS PrePost, you can notice that it's not just a set of surfaces we have, but rather an actual mesh. And what we can really see from the bottom of the channel as well is that the elements have deformed a little bit to conform to the shape of the leaflet and make sure that all the nodes are connected. So here we can really see the different parts in these views if we deselect some parts. Now the first thing we have to do is we're going to check for duplicate nodes using the element tool. Normally, if we've used the mesh connection group, we shouldn't have any. As here, for example, if we click show duplicate nodes, there are no duplicate nodes. But in some cases, it is possible with different tolerances to find duplicate nodes. In this case, we don't have any, so that's not a problem. But if you do have duplicate nodes, you have to make sure that you merge them, and then you click accept to make sure that the solver doesn't have 2 different points of information. So here, as it's fine, even with quite a high tolerance, we don't find any duplicate nodes. We don't find any free edges. We just click done. What we have to do now is we're going to save this entire entity, so the 4 different parts. We're going to save that as our fluid mesh. So we click save as, save keyword as. In the same directory, but we're going to call it fluid_mesh. .k. We save that file. And then if we go into the advanced settings, we're not going to save a lot of the information that we entered in ANSYS. In fact, we're really just going to save the elements in the nodes. So once we've only selected those two options, we save, and then we have our fluid mesh. It's ready. And now we have to do something a little additional to create our solid mesh. And the way we're going to do that is we're going to create a copy of the flap by clicking right-click copy, and then we're going to rename it again as flap. We're going to deselect the other parts just to show the part 5 we've just created. And now what we have to do is go into the keyword manager, which is in model and part. We go into the keyword manager, we select the part option, and we're going to change the part ID of the new flap we created to 44. The reason we choose 44 is because as it's part 4 in the fluid and it's part 44 in the solid, we know when we look at the K files that these two are connected. This is simply a logical way of remembering how parts are connected, but it doesn't actually physically connect them in the simulation. It's more for simplification when, as a user, you interpret the K files. And so now what we have to do is we have to create the SPC boundary for the leaflet. And the way we do that is in entity creation, we select SPC, create. As it's pin jointed, we are not going to restrict it in rotation, but however, we're going to restrict it in XYZ. And then what we do is we pick the nodes that are going to be constrained. In these cases, the bottom set of nodes. We click apply. Done. And now in fact our solid mesh is ready. What we just need to make sure is that we've deselected all the parts. We've only selected our flap 44, which we just created. And then we're going to go into save as just the specific entity of the flap. And we're going to save that as our solid mesh. So now we go into save as, save active keyword as, and we're going to save it as solid mesh. Once we've done that, we go into the advanced settings and we just select the node, the element, SPC, and all others. And then once we've done that, we click apply and we save. So now effectively what we have is a fluid mesh and a solid mesh, and we're going to open them now in a text editor. So what you can see from these files is that it's mostly element coordinates. So you'll have a part ID and then a set of nodes. And then here a boundary SPC set, which designates the nodes which are constrained for the solid mesh. And the only thing we have to do for these files is make some slight edits to make them ready for the simulation.